We will be learning resistors in series and parallel connection in this lecture. First, let's learn two resistors in series. What would be the equivalent resistance of two resistors in series? When two or more resistors are connected end to end, they are said to be in series. The current is the same in resistors because any charge that flows through one resistor flows through the other. The sum of the potential difference across the resistors is equal to the total potential difference across the combination. So the total potential add up. We have total potential equals potential of R1, which is IR1, potential of R2, which is IR2, V1 plus V2 equals delta V. We also have delta V equals I times R equivalent, so we can quickly find out equivalent resistance is R1 plus R2. The equivalent resistance has the effect on the circuit as the original combination of resistors being replaced by this equivalent resistance. To summarize, if we have resistors connected in series, the equivalent resistance is the sum of the individual resistance. This is a simple example. We have four resistors connected in series. The equivalent resistance would be the sum of the four individual resistance of individual resistors. 2 plus 4 plus 5 plus 7 give us 18 omega. We can also connect resistors in parallel. The potential difference across each resistor is the same because each is connected directly across the battery terminal. The current that enters a point or junction must be equal to the total current leaving that junction. So current are not everywhere the same in parallel connection. You can think of it as water current. You have a faucet, and the faucet was connected to multiple branches. The water going through each branches has to add up to the main branch of water current. Water current is carried by water. Electric current is carried by charges. The number of charges flowing through the main branch A1 has to be equal to the sum of the charges flowing through branch 2 and branch 3. So A1 has to equals to A2 plus A3 in this example. On the other hand, the potential over parallel branches are the same. We use the property total current of a junction equals to the current flowing through each branches, and we replace I1 by potential over R1. We replace I2 by potential over R2. We find out for two resistors connected in parallel, the equivalent resistance satisfies this equation. 1 over R equivalent equals to 1 over R1 plus 1 over R2. There is an easier equation for us to use. When two resistors are in parallel, the equivalent resistance is given by R1 times R2 divided by R1 plus R2. If we have more than two resistors connected in parallel, the equivalent resistance is given by this equation. The inverse of the equivalent resistance of two or more resistors connected in parallel is algebraic sum of the inverse of the individual resistance. the equivalent is always less than the smallest resistor in the group. So let's summarize. When two or more unequal resistors are connected in series, they carry the same current, but the potential difference across them are not the same. And then we have the equivalent resistance is given by the sum of each resistance. When two or more unequal resistors are connected in parallel, the potential difference across them are the same. The current through them are not the same. The current through each branches has to add up to the total current. We have to calculate the equivalent resistance using the reciprocal addition rule. A complicated circuit consisting of several resistors and batteries can often be simplified, reduced to a simple circuit with only one equivalent resistor. If the current in or the potential difference across a resistor in the complex circuit is to be identified, start with the final circuit found for the equivalent resistance and gradually work back to find the individual potential and current through each resistor. This is an example how we can reduce a more complicated circuit with 4 resistors connected to one single equivalent resistance. First, we have 6 omega and 3 omega resistor in parallel, which will give us 2 omega. 8 omega and 4 omega are in series, add up to 12. In the end, we have 12 omega and 2 omega in series, add up to 14 omega.